chat section for general comments or admin inquiries. The questions in the Q&A window will then be reviewed and addressed in the final section of the webinar. Finally, please ensure you are on mute to avoid any noise disruption. Many thanks. The webinar is being recorded and will be uploaded on our website in the coming days. And it's now my pleasure to hand over to Chris Hoon, adba's chairman, who will introduce our speakers and moderate the webinar. Have a good time. Thank you.
Thank you. Thank you very much, Jocelyn. I think it was exceptionally clever of the organizers of Net Zero Week to arrange these events just at a time when we all need maximum relief from the Westminster psychodramas going on. We were in a new world anyway, where we were having to rethink supply chains that have served us very well for many years. And obviously that applies to natural gas. It's extremely exciting time to be in the biogas and the upgraded biogas biomethane sector. There's a real buzz as developers dust off plans for expansion and big investors are hoving into view, people like companies like Shell and Total Energy and Marubeni. And biogas in the UK has the potential on adba's calculations to replace about 10% of our natural gas imports, and with a following wind and an effort on feedstocks, it could be more. And in Europe, in the EU, the Commission has come up with a plan to use biogas output to replace much of the Russian imports of gas that are so important in price setting and in physical supply on the continent. But today, we're looking at another particular area, and that's the rethinking of supply changes that apply to the side product of the biomethane process, which is CO2. And this is potentially a very valuable product in itself, used in many industries, notably food and drink, to put the bubbles into soft drinks, and also for keeping food fresh and for other uses. It had been produced as a byproduct of fertilizer plants, but the feedstock was natural gas, and as natural gas prices rose so high, UK production became uneconomic. So in the case of the fertilizer plants, they are suspended. In the case of one that was suspended, the announcement earlier on was that it was going to be closed permanently. So this has left UK users in a perilous position. The economics of the sector mean that it's not economic to produce CO2 on its own. And to look at this issue, we have two excellent speakers this morning who are going to be looking at where next and how the biogas, biomethane sector in particular can help fill the problem. That's Leanne Williams, adba's lead policy analyst, who's going to set the scene for us. And Future Biogas's Dr. Nick Primmer, one of the sector's leading lights, will explore the subject in greater depth. So I'm going to hand over now to Leanne to set the scene for us. Thanks, Leanne.
That's great. Thank you very much, Chris. I'm just going to check which screen you can see. Bear with me one moment. Sorry, as much as I've practiced this, it always happens this way. Can you see my complete screen?
We can see your slide now, biogenic CO2 from AD.
Perfect. Okay. So, yeah, welcome everybody. Thank you, Chris, for that introduction. I'd like to just sort of start off by saying welcome to the fourth Biogas Insights pamphlet that adba has written and is publishing. Some of you may have joined us for the launches of our previous reports. I believe our transport one was launched at Net Zero Week last year. We've also launched a hydrogen one and a food waste one, and so great to see those of you that are coming back again, or welcome to anybody who's joining us and is coming across our organisation for the first time. As Chris said, I'm Leanne, I'm lead analyst here at adba. If you're not aware, and this is your first time coming across this, adba is the UK's dedicated trade association to AD and bioresources. So we would invite any of you with an interest to reach out to us, look us up on LinkedIn or visit our website. So yeah, as Chris said, we are traditionally known for the production of energy, but today we're really going to be honing in on CO2, and more specifically biogenic CO2 that comes from AD. Sort of thinking back on secondary school biology, where we're taught about the importance of carbon and how it's an essential component of life, and one of the key reasons we exist. But as you'll all be aware, I think joining us on Net Zero Week, there's an increase in atmospheric carbon, and that is really driving climate change. And this is something that we really need to address, and we need to address it as soon as possible. And as part of this, and the purpose for us producing this pamphlet, we really need to hone in on where this carbon is coming from and what form it's in. So as in terms of setting the scene, as Chris said, reflecting on this, there are two sources of carbon, really. So there's the fossil carbon, which until recently has been locked away for millions of years underground. And it's, over the past couple of 100 years, it's been extracted, used, and it's releasing carbon into the atmosphere that wasn't there before. And then on the other side, we've got the natural carbon set cycle, so the biogenic carbon. So that's carbon that's derived from living organisms, locked in organic material. It's built up in plants through photosynthesis. It transitions through the supply chain and can and really should be recycled by organic processes and AD. So when we're looking at the increasing CO2 emissions, we're really thinking about the origin of said carbon. And really it's fossil carbon that really contributes to the greenhouse gas emissions. And as I said before, the other is really already locked into the atmosphere and into the cycle. And so as we're using fossil CO2, that's where the contribution of CO2 emissions really arises. So how does this relate to AD? Well, as I've mentioned before, organic matter contains this biogenic carbon, and as we've said, organic matter can be recycled through AD. So that means matter such as food waste, sewage, crops, industrial residues, drinks waste, there's livestock and manure waste, slurries, and then even garden waste. And so by processing all these different wastes through a digester, biogenic carbon is really concentrated within the AD tank, and then we can then sort of progress through that and really, I guess, maximize and really use that CO2. So for those of you that are joining us with limited knowledge of the AD process, apologies for those that are quite aware of it and are sort of well versed in it. But AD really takes those wastes and uses microorganisms to break them down. And through this sort of anaerobic process, it produces two main products, or sort of three co-products. So the first one is biogas. This biogas is made up of biomethane and bio-CO2 at sort of varying percentages, but generally it's around 55% biomethane and 45% CO2. And then second to that, a biofertilizer or what we call a digester is produced, which can then be used to replace organic fertilizers, in artificial fertilizers. So just focusing on the biogas, because that's really what we're looking at today. This biogas can be used to produce power, or it can be upgraded further. And by upgrading it, we can then split it into its two forms, into two parts. So we've got biomethane, which could be used for heat, displacing natural fossil gas, and then a stream of bio-CO2. And this can be used in industry, which I'll go into, or alternatively, it can be stored, which Nick will be sort of diving into in his talk. So as you know, we're really focusing on bio-CO2, and what is the focus? What's the value? So as we've said before, the UK is, well, as Chris mentioned, the UK sort of relies on CO2, particularly in a lot of its industrial processes and food and drink. So in, I think it was 2019, around 50 to 60% of all CO2 demanded was for the use in food and drinks industry. And then further to that, there's also demand for CO2 within fire extinguishers, used for medical purposes and surgery. It's also used in the energy industry. And at the moment, the demand is really around 600,000 tonnes of CO2 every year. But I think as industry develops and as innovation continues, we may actually see a further increase in the demand for CO2 as companies really recognise the ability to store that carbon as part of their processes. So, for example, in curing concrete and locking away carbon in new materials. So coming down to, I suppose, the fossil versus biogenic CO2, we need to look at where the CO2 currently used is sourced. So at the moment, a significant proportion of this is supplied by the manufacture of artificial fertilizers. So around 60% of all CO2 supply in 2019 came from the manufacture of artificial fertilizer. And then the remainder of that was coming from the bioethanol industry or imported, and that was generally split equally between them. But if we really look at the manufacture of artificial fertilizer, what we see is that there are three main producers, and this really is quite concerning, which I'll go into in a little bit more detail later. But in the UK, there are just three fertilizer plants. So that's Billingham in Teesside, that's Ince in Cheshire, and then there's Ensis in Teesside. But as I'm sure many of you may be aware, and I think at the start of June what we saw was that the announcement that Ince is going to be closed, and this is going to cause a massive issue, which again I'll go into in the next couple of slides. So just still reflecting on the artificial fertilizer and the artificial production of CO2, why is it an issue? Well, it's a really incredibly carbon and resource intensive process. I won't go in too much depth into the science, but by manufacturing just 1 tonne of ammonium nitrate to be used in agriculture as a fertilizer, the whole process produces 5 to 9 tonnes of CO2 emissions. I think what we will do is we'll be circulating the report in its final form to everybody who's joined, but so you'll have a bit more opportunity to go into this in a bit more detail as you're looking through. But I really want to highlight the stat sort of just at the bottom here that says in 2010, the manufacture of ammonia used around 1% of the world's total energy supply and emitted around 1% of total GHG emissions that year. And that's huge. So it's a really, really intense process, and it's one that we need to be moving away from if we're truly going to achieve our net zero targets. Moving on to the CO2 market and really looking at the price piece as well. The price of CO2 and the market is really governed by how close the user is to one of those 3 production plants, or soon to be 2 production plants. So as you can see here, we've got the Billingham in Teesside and Ensis in Teesside, and then Ince in Cheshire. And so what we see is that where CO2 is required to be transported, it begins to become quite uneconomical when you start transporting over 150 miles. And that's just purely on a price point. We're not really looking at the emissions associated with the transport there as well. And so secondly, and one that's caused major issue recently, as I'm sure you're all aware, is that due to the amount of natural gas that's required within the manufacture of fertilizers, as soaring energy rates start to impact the industry, it's had a real impact on the cost of fertilizers and CO2. And what that's meant is that, as we've seen over the past 6 months or so, the gas crisis has suspended fertilizer production, and that has had a knock-on impact on the CO2 supply chain. So just kind of going into the concept, I suppose, of a CO2 crisis and why it's really important that we really diversify our supply of CO2 and the importance of AD in addressing these issues. So we need to look at the CO2 crisis. So in 2018, we saw the first major crisis, and this was really due to a number of reasons. Plants across Europe, and then indeed 2 of the 3 major fertilizer plants in the UK were taken offline for maintenance, as they often are in the summer months. And this kind of coincided with rising demand. So if any of you remember 2018, it was the Football World Cup. With some glorious weather, and that really led to an increase in the consumption of cold fizzy beverages, beer, soda, and that really led to an increase in demand. And so we really found ourselves in an issue and a real demand for CO2, but the supply just wasn't there. So after a couple of weeks, Billingham and Ince were brought online again, but it did take 2 months for the market to recover, and that's a really significant time frame. Fast forward to 2021 and 22, and we've faced another crisis. So what's traditionally averaged, with energy traditionally averaging around 50 pence per therm, this has gone up massively over the past year, 6 months to a year, and peaks have been reported as high as 540 pence per therm. So that's massive. And while I think everybody's really hoping that we'll eventually see stabilization in the market, I think most of us will agree that we won't be seeing the low levels that we did previously for quite some time. And so it seems like there'll be no real respite. And as I mentioned in sort of previous slides, at the start of June, it was announced that Ince is due to be permanently closed, and I believe the government is looking for another buyer. But it really means that we're sort of on the precipice of more turmoil. And so this is where we are firm believers that AD comes to the rescue. So as we said before, it's a producer of a steady stream of bio-CO2. As of March, there were 122 biomethane plants in the UK with the potential to not just cover current demand, but then some. And not only do we offer the security of supply due to the decentralisation of these plants, as you can see from my slide here, these plants are distributed all across the UK. But we also offer security in the reduced need for CO2 to travel significant distances. So as you can see here, the distribution is significant. So as we said, 110 plants at the moment treating municipal, industrial and or agricultural feedstocks, and then 12 plants treating wastewater. I think this graphic is really good as it really shows the impact that AD and the production of biomethane, bio-CO2 can have on the industry compared to current demand. But really we need to dive into, what do we as an industry contribute now? So at the moment, despite the massive potential, just 11 biomethane plants are currently capturing their bio-CO2 from the biogas upgrading process. And so we currently supply around 80 to 90,000 tonnes. So that's just around 15% of demand. So while the potential is there, we've not scaled it up yet to fully deliver the full demand. And there's a number of reasons of that, because of that. But something that I think is, I'm just conscious that I am sort of running out of time as well. But we are now in the midst of our green gas support scheme, which is really supporting the expansion and sort of forecast to expand the industry to around 45 new plants, all with an average biomethane capacity of around 750 meters cube per hour. And we expect that most of those to install CCUS, so carbon capture and usage and storage technology onto these plants, all sort of capable of producing food grade CO2. And so really we're again looking at the potential of each of these plants to produce around 9,200 tonnes of bio-CO2 per year, which is really significant. And I think it's going to play a massive role going forward in the security of supply, in really sort of addressing those cost barriers. So I've come to the end of my time, but to sum it up, there's a massive source of biogenic carbon and biogenic CO2 out there. It's usable, as I've said quite a lot. It's a decentralized supply. We've got biomethane plants out there that are ready to go, and new plants coming online that will be upgraded. So with the right upgrading, we can match demand. And something that I haven't had time to go into today is the potential of the total sector for GHG, for greenhouse gas removals. And so there's massive scope for the industry to couple with the storage sector as well. But on that note, I think I will hand over to my counterpart, Dr. Nick Primmer. But just a quick note to say what we'll do is we'll get the links to previous pamphlet insights shared in the chat. And then what will happen is once the pamphlet has been formally published, you joining us today will have a first look, and you'll receive the first link to that pamphlet. So I really encourage you to go and take a look at the other pamphlets in the meantime, and really have a look at the pamphlet as it's produced. So thank you.
Great. Over to you, Nick.
Thanks for that, Leanne. Let me just share my screen and there we go. Is that showing well?
Yes.
That's great. Well, yeah, thank you very much, Leanne. That was some really interesting slides, and as covering the sort of utilization side of the market. I will be covering the capture and storage side of the sort of CO2 market. So between us, really looking at how to unlock that true value of this really undervalued resource from the AD industry. So just a bit of background, I work for Future Biogas, working there as a policy advisor. So Future Biogas itself is the largest producer of biomethane in the UK. They operate 11 plants, primarily located in sort of East Midlands and Norfolk area, of which 10 of these plants are biomethane to grid, generating nearly 0.5 terawatt-hour of biomethane per year. But as we look to the future, we're looking at that carbon story. And so, as shown by the CCC's sixth carbon budget, there is not only an urgent need to decarbonise every single UK sector, there is also a need to deliver carbon removals, greenhouse gas removals. And here you can see these removals are crucial to offset the unavoidable emissions. So those processes which are unlikely ever to be zero emission, you need these removals to balance those emissions. And at the moment, the UK is not delivering any greenhouse gas removals at any meaningful scale. So as we scale up to deliver that net zero goal, we are having to invent an entire industry from scratch. So by, within the next 30 years, we're going to have to, as a country, deliver up to 81 million tons of CO2 removals per year. So that is an extraordinary growth over the next few decades. So when we talk about greenhouse gas removals, there are sort of two ways of delivering that. First, you've got your engineered removals. These are things like taking your biogenic CO2, so from the atmosphere, that biogenic carbon, and locking it away in permanent storage, whether that is an underground geological reserve. There are plenty around the UK, such as Northern Lights, where you're pumping that CO2 under the sea into the rock below and storing it there permanently. The benefits of these that they are permanent. So that kind of geological storage is believed to store the gas for at least 10,000 years. Realistically, it's far more than that, but I can say with confidence 10,000 years. Very low risk of re-release and high integrity. But at the moment, it's expensive. This isn't being done anywhere at scale. So there's a lot of infrastructure to develop to deliver that pathway. And the other side is your nature-based removals. So that's anything from planting a tree to increasing sort of soil carbon. It's cheaper to deliver. It can deliver these greater externalities like increasing biodiversity, by planting a new forest. But the difficulty is it's not permanent. Trees can fall over, they can be burnt. And when things like that happen, obviously that carbon is being re-released to the atmosphere. So the level, that sort of permanence and the level of removals can be quite difficult to quantify. But nonetheless, both of these avenues are really crucial to deliver net zero. We've got to look at both of them. And luckily for the AD, it can help deliver both sides. So we've got the engineered removal side where we can take that bio-CO2 and lock it underground. And we've also got the nature-based removals. So AD's production of biofertilizer, that's very carbon rich. And again, all that carbon originates from the atmosphere. So spreading it to your land and soils, you can improve soil health and lock carbon within the agricultural land. And that's really the model Future Biogas are looking with its future plants. Recognizing that value in bio-CO2 and sort of that biogenic carbon. So tracking it through the system, we're looking at carbon capture in crops. Those crops are processed through anaerobic digestion. The energy is produced, that biogas and biomethane is used as an energy source, and that bio-CO2 is being captured and transported via the Northern Lights project and stored permanently underground. And more on that in a bit. And this new model seeks to sort of redesign the financial model of AD, or has the potential to sort of revolutionize the economic structure of the industry. So at the moment, conventional AD plants, their almost entire income is based on that biomethane production, that energy production. And much of the income is underpinned by government support. So up to about 60% of income can be from, your FIT, your RHI, your Green Gas Support Scheme. That's complete dependence on government support. And as a result as well, energy is the one and only focus for an AD plant, and such the other products such as bio-CO2 and digestate are undervalued. But if we start really concentrating on the carbon story, we can start balancing that economic model in a different way. So first, you produce unsubsidized biomethane. So this is where you're not relying on government support. There's no Green Gas Support Scheme. And so you're producing unsubsidized biogas where companies are valuing that nature of the gas. You're delivering additionality, which is really a key part as we move forwards to deliver net zero. So you're adding new capacity that otherwise wouldn't be there without underlying government support. So you're delivering extra energy, and then also with that bio-CO2, you're capturing that and removing it. And by generating a removals credit, you can sell that to companies as well, where these companies recognize they may have unavoidable emissions, and that can help balance their carbon budget. So Future Biogas itself is developing what we call Project Carbon Harvest. And this is an ambitious effort to develop 25 new plants over the next decade, 25 new BECCS plants, so capturing that carbon. And each plant will be will deliver roughly the following outputs. So we're looking at these large scale plants producing about 110 gigawatt hours of biomethane per year. So that biomethane, unsubsidized gas, is directly displacing 20,000 tons of natural gas. So a huge amount of energy displacement, carbon displacement from renewable energy. That bio-CO2 is being captured, about 15,000 tons per year. So that is carbon that will be locked away and delivering 15,000 tons of greenhouse gas removals per year. So that's a strongly carbon negative effort. And also that digestate is going to be reapplied to farms, completing that circular economy, displacing artificial fertilizers to the tune of 1,300 tons of CO2 emissions, and also delivering some nature-based solutions. Difficult to quantify, but we can start, a ballpark figure might be about 3,750 tons of CO2 removals per year as well, but on a temporary basis. And each of these plants will be fed by zero or near zero carbon crops grown under long-term contracts with sustainable farmers. So more on that here. So the project places farms at the heart of the greenhouse gas removals. So it's important to consider the current state of the agricultural system and the future ambition. So much of the current system is not sustainable. There are high use of carbon-intensive fertilizers, high use of pesticides, herbicides, and we've seen widespread soil degradation across the UK. This can't keep going indefinitely, and something has to change. And again, this is where AD can come in. And AD can be integrated into a sustainable agricultural system. You're recycling that carbon and nutrients, you're providing local energy, you're enhancing biodiversity and restoring those soils. So by linking up with farmers, we can do this in the right way. It's not a particular crop that is negative to the agricultural system, it's how you grow it. So you can implement crop rotation. So again, under Future Biogas's model, about 1 in 5 to 1 in 7 crops on a particular farm can be sent to AD and rotated within different fields in that land. So that encourages that biodiversity, minimizes soil degradation. And you can also start combating pests like black grass, which is common across the east and south of the UK. So there are benefits to the farmer. You're diversifying their income, you're providing a steady stream of predictable income over, say, a 15-year period. You're reducing their demand for fertilizers, which, as Leanne was saying, are very expensive at the moment. So you're giving that, and you're giving that carbon benefit to the farmer. So they're happy. For the AD plants, happy because they are getting a strong, secure supply of feedstock, which is one of the sort of main sources of risk to AD operations, feedstock supply. There is no dependence on government subsidy, so you're independent from that. And finally, an AD plant is really being rewarded for its environmental services, not solely the energy production, but the wider benefits. And the UK government are happy, maybe not happy right now, but they're happy because we're delivering net zero. So you're enhancing that food security, you're enhancing energy security, and you're creating jobs in the rural economy. So just finally, a tiny bit more about the Northern Lights project. So this is the project which Future Biogas is working with to deliver the removals. So Northern Lights is a joint venture between Equinor, Shell and Total. That has been really heavily funded by the Norwegian state. So to the tune of £1.4 billion support so far. They're currently on track to be the first commercial scale project to deliver engineered removals sort of around the UK. So here, bio-CO2 will be liquefied and transported to the Humber, where it will be stored. And then vessels from Norway will pick up that liquefied CO2, transport it to injection sites where it will be injected into the rock under the North Sea. Overall, Future Biogas, just as alone, under the Project Carbon Harvest, we're looking to remove up to 375,000 tonnes of bio-CO2 per year, and also generate nearly 3 terawatt-hours of unsubsidized biomethane. So this is huge amounts of energy and removals simultaneously. Thank you very much for your time. And I believe we've got some questions. Thank you.
Thank you. Thank you very much. Hello. Thank you very much, Nick. I don't know whether I'm back on screen. Thank you very much, Nick. We've got lots of questions, and one from obviously a good, practical, pragmatic audience. The first thing many people have been asking is what can developers potentially, or existing operators actually manage to get in terms of a price for biogenic CO2. They're looking online. There seems to be a sort of wide range, and I don't know whether that's been going up recently, but are either of you able to give us, and obviously it will, presumably, Nick, if you do the carbon capture and storage piece rather than it being used in the food and drink industry, then that is a straightforward policy support mechanism. And what would be the difference in price between providing biogenic CO2 to carbon capture compared with, for example, providing it to the food and drink industry or the pharmaceutical industry or whatever? Who would like to? Nick, do you want to kick us off on that, or Leanne?
Yeah, sure.
Yeah.
So historically, the CO2 price, because these artificial fertilizer companies can sort of churn it out, and the CO2 is just a byproduct, it's very cheap, a few tens of pounds per ton. But with these crises, the cost of artificial fertilizers has absolutely skyrocketed. So I think one of the most recent crises, it reached up to about £800 per ton. And that's at the peak. It's sort of been leveling and going up and down, but we're still talking £200 to £400 per ton isn't uncommon. And that's for the acquisition of that CO2. So I guess that's the utilization side, but really it's either or. And I can't say exactly for commercial reasons, but the storage value is similar. It's competitive. They're both viable routes at the moment with very high value placed on that bio CO2. At the moment, the cost of delivery of removals, it's still growing, it's being developed. So there is a greater cost for the engineered removals, but that price is going to come down as things come online and it becomes more established. And we'll definitely see that over the next 2-3 years.
I noticed too in your slide that you had the subsidy element in the gas price seemed to be quite high. Now, presumably, if you are a gas producer who has locked in future output, that's still the case. But if you're now able to sell at market prices, then the numbers are going to very substantially change for a lot of biogas producers and biomethane producers.
Yeah, definitely. I mean, the gas price is unbelievably high at the moment, and that's benefiting those plants which currently aren't locked into agreements. Renegotiating their sort of gas prices. So while that's good for the existing plants, it's still going to be really hard to find investment based on these current gas prices. They might be good for this year, next year, the year after, sure. But you want an AD plant that can operate properly over 15-20 years. And so you're not going to be seeing investment into new plants purely on today's gas price alone. There needs to be this wider, more reliable income stream to develop new plants.
Thank you for that. I've got a question which I think goes back to the presentation, but we should, I think, clarify this. And Theophine Mini asks, what is the carbon footprint of a ton of CO2 of fossil versus biogenic? My understanding is it would be clearly if the origin is biogenic, there is no carbon footprint because there's a circular process, whereas fossil, obviously, you're digging it out of the ground. But is that right, Leanne? Do you want to take us on that one?
I would agree with that. And then the only thing I would add really is that when you couple it with storage, then it becomes carbon negative, really. So I think hopefully that answers quite a simple answer there, really.
Okay, that's great. I've got a question from Sarah Ferretti, who asks, have fertilizer producers started to move away from using natural gas as far as you are aware? I am actually not aware of any other process for making synthetic fertilizer other than the Haber-Bosch process. Maybe there are some. I'm no technologist. I'm an economist. So please enlighten me. Either of you?
I am not aware of anywhere that is, and I would say that where they are, I would imagine it's on quite a very small scale, if they even are.
Yeah, I completely agree. I'm not aware of any other process. I think that's why AD plants are now seeing, and we've never seen demand for digestate like it, because suddenly farms need new supplies of nitrogen, and organic fertilizers are a great way to get your.
I mean, we've had a question from one of our attendees about the developing world, and this is perhaps quite crucial there too, because there are some extremely scary calculations of what happens to global agricultural output, to yields without synthetic fertilizers, and the worst I've seen takes an 8 billion global population down to a sustainable 4 billion if you don't use synthetic fertilizers. So are there realistically an ability to build up biogas and digestate production to substitute, particularly in the developing world? Are either of you aware of that sort of potential?
Yeah, I mean, I would say it's probably Nick. Nick was sort of lead author on a report that really dived into the global potential and the ability to really capture and the importance of harnessing the bio waste and the feedstocks there. I would say that there's a piece to be. I guess it's all about knowledge share as well, both from a technical perspective, but also from a policy perspective. Looking at how we can really fully capture those organic wastes and what's the best way of processing them within those individual countries. Because I think there's, dependent on the types of waste available, will change the way in which they're collected, and there's, I guess it's not necessarily always a one solution fits all. But yeah, Nick, I don't know if you've got anything more to say on that.
No, I think that's it's a really good point. And just to add to that as well is I think we're at least in the UK, we're seeing farmers in the face of really expensive fertilizer prices start experimenting a bit more with productivity and how they are operating. And I know for a fact that some farmers have started easing back and trialing, instead of spraying 200 tons of nitrogen per hectare, they're trying 150, and they're actually finding that it's marginal reductions in productivity for quite a significant reduction in application. So yeah, sure, like if you reduced it to zero, there would be a big impact on productivity. But we can certainly start wheeling that back, perhaps replacing more of it. And it's a law of diminishing returns. It's not like the more you put on, the more you get. So finding that sweet spot between how you're applying your nitrogen and making sure that you're still maintaining your crop yields.
Thanks for that. I've got a question here from Thomas Minter about some of the practicalities involved. Can the panelists give some insight into the state of the art in terms of CO2 systems that are out there that are commercially available? Are they at scales relevant to AD plants, i.e. 0.5 to 4 megawatt electrical equivalent, for example? Who'd like to kick off on that?
I mean, I would say that my in-depth technical knowledge is probably less so than the policy side, but the technologies are out there. I think there's a number of different ways that you can upgrade. I think generally they're more suited to larger scale, but they are out there. I realise I just spoke over you there, Nick.
No, not at all. Yeah, completely right. I think it's definitely skewed towards the larger plants, probably a bit larger than the current industry average in the UK, or at least the CHP average. So you're certainly looking for your larger plants, perhaps about a 10 megawatt or maybe 7 or 8 megawatt biogas capacity. And I think as well, like particularly for the utilization market, they are particularly looking for those extra large plants that can produce enough bio CO2 to fill a truck a day. So that's about 20 to 22 tons of CO2 per day. And that, because from the user's perspective, that's enough to, you know, meet their demand, or at least provide that security of supply. You know, because AD plants, they do have their downtime, maintenance, and their, you know, the downstream users just have to be conscious of that availability of supply.
But Nick, just to be clear on this, if a plant is big enough to have paid for the biomethane upgrading of the biogas and is therefore injecting into the gas grid, maybe, does that mean it's likely that they should be looking at a way of capturing the CO2? I mean, is that the sort of scale? Anybody producing biomethane at the moment, should they be looking at this?
It's a good question. I mean, with the current prices, yeah, I think it would be hard to argue not to. It'll be interesting to see how that develops over time, and if that price does keep high. I imagine it will, but that would be the kind of key question. But yeah, certainly, I think if you're already upgrading your biogas, the bio-CO2 is just a byproduct. It's being vented to the atmosphere.
Yeah.
The equipment to capture it is expensive. You're probably talking about a couple of £1 million. You know, that's a big investment, but I think increasingly it will be commercially viable, whether that's utilization or storage. It's yeah.
So for utilization and storage, is there actually, excuse a sort of dumb economist question, but is there actually any difference in the technology or the capex?
No. So when you store it, you're going to need food grade CO2, which most membrane upgraders will produce a stream of high grade food grade CO2. So obviously food grade CO2 is also needed for food manufacturing. Arguably you can get lower quality CO2 for other applications, like in abattoirs and you know, maybe greenhouses. You don't need that super pure stream. But yeah, the technology to upgrade and liquefy that CO2 is going to be the same whether you're then taking it to storage or then taking it to utilization.
We had a specific question on the capex cost. You've given us a figure of £1 to £2 million, which obviously is going to put it out of the range of a lot of smaller AD plants, which are not doing biomethane upgrading already anyway. Are you aware of any lower capex cost options that could be used by AD plants that are not currently, say, doing biomethane upgrades? Well, they have to do biomethane upgrades effectively to get.
Yeah, I think broadly speaking, you have to upgrade your biomethane to get that stream. I mean, there might be technology to capture that CO2 off the end of a CHP, you know, just capturing the exhausts. Certainly there's technologies that are looking to do that from, you know, things like DRAX. So you take your exhaust fumes and clean it up to a stream of CO2. I'm not aware of that happening at AD, of that side of the AD.
Yeah, I've not come across it either, but I would say to anybody, I guess there's quite a few people here, and if you are aware of those technologies, that is something that we're always very interested in, because we'll need every solution sort of possible, really, and to be able to access that, as Nick said, would be great for smaller scale plants as well. So always on the lookout for those sorts of technologies.
Just there's a question here from Darren Rule, which I think is pertinent, because I know that other people have talked about this when we were recently at the Birmingham Expo. Do you think it will be difficult from a marketing or public perception viewpoint in using bio CO2 from waste, particularly from sewage, for use in food and drinks for human consumption? Now, presumably, once it's upgraded, it's the same gas wherever it comes from. But is there a perception issue? Is there a problem in the market in terms of buying it?
So I guess there's always the risk of the perception issue, but I think that's where it comes down to the regulators and the government to send clear signals about what is and isn't acceptable. As you say, so DEFRA, I think back in, I think it would have been March now, or sort of around springtime, were quite clear on their support for the use of waste-derived bio-CO2 as part of sort of some ongoing work to help, I guess, develop that side of things within the industry. And I think that you just have to be very mindful of the compliance requirements. So you need to make sure that you're compliant with a set regulation standard. I think it's 231 something, but I can send it to the group if people are interested. You also need to be quite aware of making sure you know when the CO2 has become hit that end of waste point, and then therefore no longer a waste. And there's really an opportunity there to engage with the Environment Agency, who is the regulator, to secure like a second opinion there to show that it has achieved end of waste. And I think that as long as you are, I think with clear signals and making sure and being very clear on demonstrating that you have met those criteria, then we should be able to move away from that perception barrier. But again, it's around as well. I think it's twofold there. It's the communications and giving consumers the confidence, but also making sure that as an industry, we're very we're producing top quality products, and making sure that we're adhering to those regulations. So.
Okay, I suppose one of the sort of slightly odd things about that issue is that when it comes to water, the food and drink industry appears to use water from the mains very happily, and yet that water has been through, in most cases, exactly the same sewage plants that they're saying would be a problem if they were potentially to accept bio-CO2. So, I mean, there may be a sort of an issue there to simply face down at some point where, the food and drink industry needs to recognize what it's already using. I
think that's a really good point. It's a really good way of articulating the situation. I completely agree with you, Chris.
I've got a question here from Nick, did you want to add anything?
Nothing to add.
Okay. I've got a question here, another one from Theophile Mini. Are there any bio-CO2 certificates existing either for carbon removal or for use currently? Is there any sort of certification?
So for the removal side, that's being rapidly developed. So your big projects, your Northern Lights, hopes to start, at scale injecting CO2 within the next, I think it's mid next year. So for that, so that is like almost like a deadline for this process. And there are various initiatives and organisations starting that methodology to account for the carbon and the sort of life cycle emissions of delivering that, and then verifying it, monitoring it, and accrediting that removal with a certificate. It's been done for other products like biomethane, so there is no reason why it can't be done for this, and work is well underway. I'm fairly confident that they'll be ready imminently.
And is that, by the way, who will be taking responsibility for that scheme?
So it would be third-party accreditors. There's the CCS Plus is a big one at the moment, but also your I'm forgetting the names. The Coalition for Negative Emissions is also exploring this issue. So there are plenty of projects looking to develop these kind of methodologies which any plant could start applying.
And would that be good enough to use to cash in terms of carbon credits in the carbon credit market?
Yeah, it's an interesting one. So the UK ETS at the moment doesn't recognise removals, but just 1 month ago, they concluded a major consultation looking to completely rehaul the UK ETS. And a big part of that, a huge chapter, was all about carbon removals and making this idea of making the UK ETS a kind of centralized government-backed scheme to give value and credibility to removals. So every sign from government suggests they will do that. Exactly what it looks like is being developed as we speak. But yeah, I think the removals are going to be a really key part of the ETS.
And presumably that will short circuit what you're proposing to do with your exports to Norway. I assume that Norway is paying.
Yeah, no. So it wouldn't short circuit. It will complement it. So you have these voluntary markets whereby any company can state their, say, net zero goal, and you've got these compliance markets where companies must get their emissions in line with targets. So both of these work together, and actually having a strong market in them both will support the development and investment into the removals. So by claiming a certificate through this pathway, UK produced using Northern Lights, the credit would be given to that person, that delivery, and the income gain from it might be divided up between Northern Lights and, say, future biogas, but that is the income potential. So there will be costs to use that delivery pathway, but it will still be enough to incentivize that delivery.
And just what's the situation on the EU ETS? Is there actually a payment now?
I believe they're also looking at removals. I don't think they've implemented it yet, but I've heard sort of rumours that this is the UK trying to kind of one up the EU and the UK ETS. If they can take a lead on the removals, they'll place themselves at the sort of forefront of an industry must be big in the future. So
right.
No agreement.
I've got a question here from Mr. van den Woede of NG in the Netherlands. Is the use of bio CO2 following specifications from the IGA coming from AD, is that allowed to be used in fizzy drinks in the UK currently?
Yeah.
Right.
Yeah, so that's the specification that classifies it as food grade, and there's no technical reason why it shouldn't be allowed. There's the perception issue that may or may not come into it, but yeah, no, if it meets the standard, it can be used for food grade.
Okay, I have Richard Hudson question here. Will bio CO2 compete with or complement CO2 from waste to energy plants and carbon capture and storage and use facilities?
That's a very interesting question. I think, I guess it's how you're framing it and what elements you're, comparing between the two. I think energy from waste has a specific niche and it should only be used to process a certain amount of a certain type of waste. We are very much, and I think, environmentally, waste should be being recycled through organic waste should be being recycled through AD. And so I think, therefore, we need to prioritize the development of that industry and the use of the co-products from that industry. I'm quite actually just thinking about it. Does CO2 production from energy from waste rely on organic material in the feedstock stream? Because if that is the case, then it's to be fully recycled, it needs to be going to AD, and therefore the CO2 needs to be used from the AD plant.
Okay. I've got a series of questions from different participants about pricing again. Obviously, a lot of keen interest in this. Are you able to share any insights into the price of CO2 currently versus crisis, and whether there is a price premium for biogenic CO2? It seems to be very difficult, this, because if there's a price premium for biogenic CO2, and if somebody's actually creating CO2 as a stream from fossil fuels, presumably they have to pay. And who's policing that?
It's a very good question. I think it's off the top of my head, I don't think I can quantify the price of it. I know previously there was discussions around it sort of going up fivefold from sort of £200 per tonne towards the 1,000, as Nick said, £800 to £1,000 per tonne mark. In terms of policing, I think, I don't think the pricing is really tied to the carbon intensity necessarily. So I guess it's at the moment, without that carbon price being integrated into, I guess, pricing systems, it's not. Maybe Nick will disagree with me there, but I think realistically it comes down to, as I said in the presentation, sort of location, how close it is to source, how the cost of energy at the time.
Yeah, I think you're right. I don't think at the moment I'm not aware of any price premium for the biogenic origin of the CO2 gas. But I guess interestingly, I think there will be a premium as removals and storage is scaled up, because every single plant will have two options. They can either go for removals, which does recognize the kind of biogenic carbon aspect of it, or they can go to the industrial use side. And if they aren't recognizing the biogenic origin, then there might be this play in the sort of price. Ultimately, most plants, I presume, will go for the highest buyer. But yeah, I think that will be quite an interesting playoff, and ultimately benefit both sides. Should create a strong competition across the market. As well, just a sort of anecdotal evidence, I heard as a kind of rule of thumb that if you can get £150 per tonne of CO2 reliably for 5 or more years, a biomethane plant should strongly consider looking into sort of a bolt-on capture unit. So, and with the prices at the moment well into the sort of 200 plus, yeah, maybe places should really consider it.
Thank you. I've got a question here. It's an interesting one, which may be outside your experience. I don't know, but let's ask it. Dinesh Sankolkar asks, how does the cost of biogenic CO2 compare with the cost of atmospheric CO2 captured using engineering solutions? Direct air capture is pretty early days I'm not aware of a commercial scale direct air capture plant, but are either of you?
I don't know about the costs. I just have heard countless times how expensive it is, especially with the energy prices at the moment. So they're incredibly energy intensive to capture atmospheric carbon dioxide directly. So the carbon price would have to be through the roof to match the electricity price you're kind of using for that. But as a price, so in the air, the CO2 comprises just like 1% of what constitutes as air, whereas inside a digester, CO2 concentrations are 1,000 times greater than open air. So instead of essentially sieving air for those couple of molecules of CO2, it's far easier, far more efficient just to go to an AD plant where it's ready, really high concentration of pure CO2 is available. So certainly the costs of capturing it, when you're looking at it as a bolt-on to an AE plant, is much more cost competitive.
I've got a series of questions on digestate, and one of them is simply, is the farming industry ready to use digestate on the scale potentially which the biogas industry could produce if it ramps up in response to the Ukraine crisis, as the Commission would like, and as a lot of the big players seem to be assuming will happen? I would
say, when actually looking at We know that from the biomethane plants that are operating in the UK at the moment, they can match demand. So I don't think that the question around whether the farming community can deal with additional digester arises. I think that that's maybe a separate question, because I think that the availability of that CO2 is there now, and it's in quantities of digester that we are already dealing with. I think, land bank availability and the ability to use said digesters that are being produced is something that, is something that we have to really consider as an industry when we're expanding and building new plants. But I think, we are seeing more and more demand for digester. I mean, artificial fertilizer, so ammonium nitrate has increased sort of threefold over the past 2 years. So, I think digester is becoming, it is in greater demand, and it's going to get worse as, the next year or so, in terms of the lack of access to artificial fertilizers. And so I think that, and there's the quality protocol at the moment around AD is currently undergoing an overhaul as well, with the potential to look at new markets. So I think that it's a system-wide thing that needs to be dealt with. I think there is need to transfer from the use of artificial fertilizers to organic fertilizers. We can't keep using artificial fertilizers at the rate that we do. And so I think it's about being smart with where it's used. But in terms of being able to ramp up CO2 supply, I don't think that is necessarily relevant to the increased use of CO2 from AD.
Okay. Nick, did you want to add anything on that?
No.
I've got going back to the issue of biogenic CO2 being used in the food and drink industry, and I have a specific question. Has Coca-Cola and PepsiCo not said that they will not use CO2 from AD? Are you aware of anything they've said on that?
I'm not sure. I wouldn't want to speak for Coca-Cola or PepsiCo really. But I would just say that I know that PepsiCo obviously are exploring low carbon options in other areas of their supply chain. And I think that it would be very sensible for them to also consider using bio CO2. And I imagine, I think bio CO2 is not just produced from, wastewater and food waste, but it's also about industrial processes. So I would be very surprised if somewhere along the line there isn't the opportunity just purely from their supply chain to make use of the CO2 that's being produced there.
Okay. I think, Nick, sorry, did you want to come in?
I was just going to say, I'm fairly confident that Pepsi already used AD CO2.
Okay. That sounds good. Unless they have a major reputational problem of one bit of the business not knowing what another bit's doing. Sounds as if that sounds like quite convincing. Can I just tracking back on the digestate issues? One of the problems maybe is a question here about standardization of digestate and whether farmers know what they're getting. Do either of you know of any schemes for making sure that digestate is a quantifiable substitute for what you can get from the synthetic fertilizer producers?
So I would say there's the ADQP, and that sort of relies on RB209, which are, I guess, averages for nutrient content. I think regular testing will demonstrate what is in the nutrient content of the digester. And I would also say that there are technologies out there that can further process the digester to produce pelletized products that are consistent in their nutrient content as well. So I think it's, there is inevitably some variation, I think, if you're really drastically varying your feedstocks. I suppose from an industrial perspective, generally, if you're sort of producing the same things routinely, then I would imagine that there is quite some consistency in the digester there. So I think it's around routine testing, but I'm not sure whether there's a standard specifically to demonstrating consistent nutrient, but yeah.
Okay. I hesitate as we're coming to the end of this webinar I think we should end after an hour and a quarter in about 5 minutes. And I want to give you both the last word to sum up if you would like to. I hesitate to open up a debate, but there are a number of questions, I'm afraid, inevitably about the feed versus fuel debate here. Would you, either of you, like to say whether this still has any mileage, or do you think that the AD industry has effectively tackled, through the points about rotation of crops and about cover crops, some of the concerns that did exist about whether growing crops for a use in AD was going to be depriving people of food?
Yeah, I can touch on that. I mean, I think it's a common misconception, or at least an oversimplification of a big issue. You know, we have a finite source of land, but multiple problems to address. And actually, thinking of an individual plot of land, you know, a single field as a single use, you know, either produces food or either produces fuel, is incorrect. When actually, to be sustainable, you know, to really sort of transition to sort of sustainable agricultural practices, you've got to be thinking about crop rotation. So, you know, 4 crops in a row, you know, you can alternate, you know, go from wheat to, you know, wheat is your value crop, and then the next one could be some beans to help lock in nitrogen into the soil, and you can go back to wheat. And you know, these are the kind of decisions that all farmers are going to be facing at the moment. And break crops, cover crops, are a really big part of that, to protect the soil and you know, ensure that you're not losing your critical topsoil. So there's no reason why maize for AD could be integrated within that crop rotation. So yeah, 1 in 5 crops on that particular field would be sent to AD. That's sustainable. It has minimal impact on food production, and you're delivering a greater benefit, such as energy generation and carbon capture and storage. So of course you've got to do it right, but I think solutions like this are not just possible. I think they're essential if we're going to deliver net zero. And you know, throwing the baby out with the bathwater. You can't just sort of say, yeah, no energy crops. Because if you do that, we're not going to reach net zero.
Yeah, I guess just to add to that, sort of I echo Nick's comments around making sure that they are sustainably integrated, and they can be sustainably integrated, not just in a way that allows them to be grown without harm, but as you said, you know, they can have a positive impact. I think as an industry, we need to move forward in a way that, you know, we are making sure that we are really only securing feedstock that is grown in those ways. And I think that we need to make sure that our industry is aware that those are that's the way to do it. You know, previously we've produced our Good Crop Guide. There's you know, we have conversations within the industry, and it's something that, you know, we don't want to ignore. It is something that has to be considered. I think I would just say as well that when we have the conversations, and sometimes when I deal with people who aren't necessarily within the industry, there's almost a misconception that AD solely relies on bioenergy crops, and that's just not the case. You know, as I've said before, there's millions of tons of other feedstocks as well, and crops is just a very small proportion of the potential of the industry. So I think it's also about addressing, from an industry perspective, the the misconception there that it's just energy co-ops. But, you know, when you look at the CCC's recommendations around bioenergy, as Nick said, it's something that has to be integrated into our net zero equation. And I'll leave it there.
Thank you very much. I think we're coming to a natural end for the webinar. I think the slides will all be available on the adba website. Is that right, Leanne?
Yes, and there'll also, I believe, a recording of the session, the slides, and also a copy of the pamphlet will be emailed out to everybody. But I'm sure Jocelyn will give more.
Yes, I can confirm that it will be followed up. Everything is being recorded.
That's great.
We will circulate the links to all the registrants. I think
as people get very interested and begin to think of biogenic CO2 as a potential revenue stream for plants, they're obviously going to be looking on the website as well for things like what is needed for purity and so forth, selling to the food and drinks industry. And I assume that we'll be making all of that available as well. Let me give both of our speakers a chance just to wrap up what the key messages are from today's webinar, and then we'll over and out. Nick, do you want to go first?
Yeah, sure. I guess it's just to underline that point that there is an urgent need to scale up greenhouse gas removals in the next 30 years from 0 to 80 million tons of CO2 per year removed. So that's a pretty monumental task, and I think AD is so well placed, adapting your current infrastructure and building these new plants. It's a really promising, the technology is established and this side of the industry is really promising. So it'll be interesting to see how it grows in the near future.
Leanne, thank you.
Yes, and then I would just say, I guess reiterate that the potential is there to meet demands now. As I've said before, it can really address the centralized issues with the decentralized supply. It can address the cost issues, and I think really importantly as well, just circling back to the wider energy piece, is that not only is it not relying on fossil fuel, but actually it's producing a renewable gas, which is essentially sort of mitigating the carbon, heating homes, producing a digester, and so it's really is a win over.
So actually, really quite an important bit of the net zero. People often forget net zero means that some things are going to go on emitting, and therefore we need some things to actually be extracting greenhouse gases from the atmosphere, and this is potentially one of them. Jocelyn, do you want any final housekeeping points before we leave the meeting and thank?
Yes, first of all, I would like to thank all our delegates for joining. We've had a record number of attendees and a huge amount of questions, which we will try to respond separately afterwards. They've all been recorded. I just wanted to thank you, Chris, for a great chairing of the event. And just to say again, everything is going to be recorded and placed on our website in the coming days. The report will be circulating to all the delegates as well. It's really a topic that is very popular, and I'm sure we'll look to do more of those sessions, which I hope you've all found very helpful.
As they say, this one will run and run.
Yes.
Thank you very much, everyone.
Thanks.
Thanks all.
Thank you.
Bye-bye.